So in this first portion of my explanation of energy, I will be talking about the conservation of energy. So while energy can change in forms, the total energy in a closed system will always be conserved. So that means that the sum of kinetic and potential energy, they can be referred to as mechanical energy in the system. A good visual example of that would be a pendulum. So at the top of the swing, it is at full potential and no kinetic energy. And at the bottom of the swing, it is at full kinetic and no potential energy. But the sum of these two is the mechanical energy, and the mechanical energy is constant throughout the whole system. So if the mechanical energy equals the sum of potential plus kinetic, we can use these expressions. We can use these expressions to represent this scenario. So it would be 1/2 mass times velocity squared plus gravity times height. And if this portion is conserved, then that means that 1/2 mass velocity initial plus gravity and height initial will be the same as 1/2 mass velocity squared final plus gravity times height final. So the problem reads, a block slides down a 250-meter inclined plane as shown in the picture. Starting from rest, what is the speed of the block when it reaches the bottom of the incline? So basically, we can start with point A, point B, and then in this case, mechanical energy initial will be equal to mechanical energy final, because every force acting on this block is conserved. And so in that case, we could use potential energy, because at the top there's only potential energy. We can make that equal to the kinetic energy over here, because at the bottom it's only kinetic energy. And for these, we can use our expressions equals 1/2 velocity or mass velocity squared. And in this case, we can cancel the mass, and we get equals 1/2 v squared. And then we would multiply both sides by 2, in which case we would get 2g h equals v squared. And now we can just plug in our numbers. So we would get 2 and then 9 point A, what equals what our velocity squared is. And or wait, my bad, I forgot to add the height, times 250 meters. That would give us our final velocity. So our final velocity, if we plug this into the calculator, would be 9.8 250. We would get a total of 4,000 square root of 4900, because we have to square it. So then if we just get the square root of that, that would make the answer 70 meters per second. In this portion of the video, I will give an introduction to work and energy. So work is action done on an object that displaces the object. So the most basic example of this is that this person pushes the box 10 meters. The work is the magnitude of the applied force. So if the applied force is 100 meters and the displacement is 10 meters, because work is just force times displacement, then that would make the work in this scenario equal to 1,000 Newton meters, which is equal to the unit of joules. But only the components that are parallel to the displacement count towards work. So for example, let's say this box is being pushed at an angle that goes towards the displacement, but also down. Instead of work just being force times displacement, it would be work equals force times displacement cosine, because work that isn't in this direction, towards the direction of displacement, it's not accounted for. So we would have to find cosine in order to find the amount of energy not being used towards work, basically. And then the third part of this is a very important part of this is that work can either be positive or negative. So if we have this person pushing the box this way, let's say with pretty big force, and then his little brother pushes it this way with not that much force, this can let us know if the speed changes, just depending on the applied force. So in this case, let's say there's 100 newtons and he's pushing it 50, it will continue to move this way, but there's negative work being done this way. So it's always important to remember, because if this force was greater than this force, then the speed would be changing the other direction. I will be going over a practice problem. Practice problem about work and energy. So problem reads, a 70 Newton force is applied horizontally to a 10 kilogram block that is at rest from a displacement of 200 meters across a frictionless surface. First question is how much work is done by the force. Second section is where's the final kinetic energy. And the third question is how fast is the block moving. So for the first part, it should be really easy, because in this case, it is only being pushed in the x direction, the direction of the displacement. It is not being pushed at an angle, so we don't have to use cosine. We can just do work equals force, which is 70, times displacement, which is 200, and that would give us work equals 14,000 joules. And since there's really only one force being applied on the object, the work, this is the net work of the whole system. So we can say that the work net is equal to potential energy final minus potential energy initial. But since at the start there's no kinetic energy, we can just say that the work net is equal to final kinetic energy, and the work net, as we said, is 14,000. So final kinetic energy would be the same as 14,000. I forgot to specify what units this is. This is Newton meters, which can also just be referred to as joules. So for part C, we want to find, what was the question for part C? Oh yeah, the velocity, how fast it's moving. So for final kinetic energy, we can use our expression 1/2 mass velocity squared. We know that our mass obviously is or first of all, we know what this is because we just solved it. And we know that our mass is 10 kilograms. Now we're just going to solve for the velocity. So velocity squared equals, that would just be 5, so it would be 14,000 over 5. So we divide 14,000 divided by 5 is 2,800. Part of the video got cut out, but I had just gone to the 2,800, and at that point it's just v squared equals 2,800. So you just have to get the square root of that, which is 52.91 meters per second. So the final velocity would be 52.91 meters per second. And those are all 3 parts.